All right, so today we're just going to continue where we left off. We went through this entire demo of creating a book structure in C, right? And then a bunch of utility functions to allow us to create books, to print them, to convert them to a string, et cetera, et cetera. And then, that took us a good while to introduce, but then over here in Java, it was really, really quick. We were able to do the same thing in about 10 minutes here because first of all, we'd already done the design, but also because of our IDE. You can go up here to source and you can generate a whole bunch of boilerplate code without really worrying about too much details, right? So I wanted to continue there where we left off, that we created this book, this author class. We'd ended up not creating a date class because it was already built into the language. Local date is a date object or a date class that that has all the bells and whistles already created and implemented for you. For example, there's no such thing as February 30th. An attempt to create a local date that represents February 30th in any year will result in an exception being thrown, right? So again, anytime you've got something built into the language or built into a standard library, don't reinvent the wheel, just reuse it, okay? So now let's come back over here to our demo and look and see how we were using this. Again, we were opening this book.csv file, right? And it has all 5 of those pieces of data. Our report here was I wanted to keep track of the highest rated books so far, right? And so what we do is we go through them all, and then we create an author, we create the date that it was released. We'll just assume that it's on the January 1st because we don't have that data. We'll create a book. Finally, we'll create the book, and then we'll ask is the rating greater than the rating that we've seen so far? And we started out by only keeping track of the title because that's all we had, right? So what I want to do now is I want to change this so that we're actually using this class to its fullest extent, right? So I will keep track of the highest rating, but I will not keep track of the title. I will not keep track of the book author because those are built into the class now. Instead, what I'm going to do is I'm going to just simply keep track of the highest rated book, all right? Now, I'll initialize that, say, to null so that I don't get a compiler warning or anything right here, right? And then what we'll do is we'll come down here, and if the rating that we read from the file is greater than the highest rating rated book that we found so far, then instead of just updating the title and the author and having a bunch of different variables, I'm simply going to update the highest rated book to be this current book B, right? Highest rated book, I think it was, yeah, is equal to B, sorry, mistyped. I called it highest rated book, right? Highest rated book is equal to B. There we go, I must have misspelled it somehow. What did I misspell it as? Oh, I misspelled it highest, there we go, okay? All right, but you know what? I could keep track of the highest rate. I've eliminated a lot of variables here. Could I eliminate this variable as well? Right? I could by simply just asking, not the rating here, but the current book's rating, rating. Right? That's what's in the book class, right? It's rating. If that's greater than the highest rating that you found so far, then update the highest rating to the book's rating, B dot book rating. Right? Except that that's not going to work at least the way that we've designed it. So tell me, let's go ahead and find out why the compiler is having a problem with this. It says that the field rating is not visible. Change the visibility of rating to package or create getters and setters. So what does that mean? Well, let's come over here to the book class and understand what private means. Private means that only the class can see it. Nothing outside of that class can see it, okay? So this is where we're getting into the second part of encapsulation, right? Remember, what is encapsulation? It's the grouping of pieces of data that act together, that define one logical unit. It's the protection of data from the outside world, right? And that's where these keywords private come in. Right? Let's go ahead and define what they are now, right? So visibility, right? Making a member variable private means only the class can see it. Right? This is what we mean by visibility. Only the class can see it, and therefore nobody else can change it, right? Nobody can, like no outside code can access or change it, right? Which is actually a very, very good thing, right? Because it leads to more predictable code. If it was not, private here, if I instead made it the alternative, which we've seen before, is public, then these issues go away. Right? Now we still have an issue down here, the highest rated book that we'll go ahead, but that's just printing though. We'll go ahead and come back to that in a second. But this issue goes away. But at what cost, right? So now what essentially has happened is we've made this variable into a global variable. Any piece of code can see this variable. Any piece of code can change this variable. Therefore, you need to test for the eventuality that any piece of code will change this variable. For example, what if I did something like this? b.rating is equal to 10. Right? Remember that the rating scale was on 0 to 5. Is that a valid rating? Nope. Right? So by making it private, we're making sure that nobody can change this, right? Making a member variable or method. Both of these apply to methods as well. Public means any piece of code can change, can access or change it, right? This leads to a lot of chaos, right? A lot less predictability here, because if anybody can see that variable, anybody can change that variable, right? So what is a good design principle here? Design principle, right? Principle. Make all member variables private, right? Unless you have a very good reason to do otherwise. And very good reason is caps on all that. A very good reason. There has to be a damn good reason for why we would want to go against this, right? Not just because I want to make it easier, right? I want to make it easier so that I can access that variable so I can compare it to something else. There's a much better way of doing that, right? Instead, control access through getters and setters, right? Functions that allow the outside outside code to access or change the variable values, right? So what would that look like? Let's come over here to the book class, and let's just do one manually here, right? So I want to be able to access the rating so that I can compare it to the highest rated book that I've found so far. That means that you want to get the value of the rating. Well, that's a double. So get rating, right? Rating. There we go. Return this dot rating. Okay, we'll talk about this keyword here in a second. Now what I can do over here in demo is not access the rating directly, right? Keep it private. And if you need to access it, go ahead and do so by saying dot get rating. There we go. Because now attempts to change it to an invalid value, b.rating is equal to 10.0, right? Perfect 10, right? Now we've controlled access to that. Nobody can set it at all, but you can still access it. If you need to use it, fine, we'll give you a copy of it. Remember, this is returning by copy, just like passing by value, or this is returning by value, just like passing by value, right? You're not able to change the actual value that's stored in the class, okay? All right, so great. Now we've got a getter here, right? Except that, we might want to access the author, the title, the release date, et cetera, right? Well, that's fine. If you don't like typing code, again, go up to the source, generate getters and setters, and I'm going to select them all, right? And we're going to see what this looks like, okay? There we go. It generated all these things for me. For example, get author, right? Get title, title. There are some programming languages, and Java is probably soon to be one, where you don't even have to generate this code. Instead, you use the keywords get and set, and it'll automatically inject the code for you. For example, C# does this. Every time you define a variable, you can, and I don't know what the syntax for this is, off the top of my head, but you can go ahead and annotate this with get and set, and that automatically generates the code when it's compiled for you. Right? But otherwise, there they all are. Right? Now, why would this be nice? Right? Well, remember that we're not allowed to set the rating here to anything that's invalid. Right? If you do, what I'm going to do is I'm going to throw that back at you as an exception. So if the rating is less than 0, or the rating is greater than 5.0, right? It's outside the scale. So I'm going to throw this back as a new runtime exception. Right? Attempted to set an invalid rating. Right? And then we'll go ahead and echo that out to them of what they tried to set it to. Right? So that now over here in the demo, if I do try to do something like that, say b.set rating to 10.0, right? Now that's going to result in an exception. Let me go ahead and get rid of this temporarily so that we'll see this being done. Attempted to set an invalid rating 10.0. Right? So getters and setters allow you to do number 2 of what encapsulation is. Protecting that data from the outside world. Protecting it from changes, unpredictable changes. Protecting it from invalid changes. Right? You can also do that in a constructor, by the way, up here when you originally create everything, right? Then you can go ahead and do some error checking there as well and throw an exception if you want to. Okay. All right. So that's why you would want to allow, prevent access, or getters, setters allow you to control access and do data validation. Right? We're not going to let anybody set a title to be null because title is required or something like that. Just like this over here, a local date. If I attempted to create a local date with an invalid value, local date foo is equal to local date dot of, right? So 2022, is this a leap year? Nope. So is February 29th an actual date? Nope. Right? Invalid date, February 29th as 2000. Oh, wow, that's a really nice message. 2022 is not a leap year, right? And I wonder what it would say if we tried like February 30th, which never exists in any year, right? That invalid date, February 30th. Right? So it allows you to make sure that all your data, when you create it, that you can't create instances of data that are invalid. Okay. Now let's go ahead and go down here and fix what we were originally doing. Right. With the highest rated book. Right. There we go. And was %s and then highest rated book right there. With a rating of whatever. Right, there we go. The highest rated book was Harry Potter and the Deathly Hallows. It was released in 2007 with a rating of blah, blah, blah. And now I don't even have to have this part anymore. Right? Because that's part of my class. Right? It is encapsulated in the class and grouped together with the other data so that I don't have to keep track of it separately. Right? Great. Right? So, getters and setters allow you to control data. Lack of any setters and all private variables make your class immutable. Where have we heard that word before? What class is immutable? Strings, right? Once you've created them, you cannot change them. String Builder is a mutable version of strings. But why is this good? This is a very good thing, right? Again, capital V, capital G, capital T, right? It gives you thread safety for free. Right? If you want to, you can define other constructors, right? If you, okay, my book rating has changed because somebody, a new review came in and now it should be, instead of 4.62, now it should be 4.63, right? Well, I'm not, if I make the choice to not have these setters here, right? In fact, let's go ahead and get rid of them. Set title, get rid of that. Set author, let's get rid of that. Set release date, let's get rid of that. And I will leave this, but I will comment it out so that we're not able to do it. Right? but I really want to because Harry Potter now has a new review in, right? What I want to do is I want to say set the rating to 4.73 or something like that. I'm not able to do that because of my choice to make it immutable. That doesn't mean that I don't have to make that design choice, because again, that is a very good thing. You're going to find that pretty much everything that's built into Java was built with thread safety in mind from the ground up. Strings are immutable, big I integers are immutable, big D doubles are immutable. Most classes are immutable, that you cannot change them, right? Because again, it's thread safety. You get it for free, right? So what I want to do is I want to define a different type of constructor. Remember that a constructor is how you construct things, right? I want a new book. Well, this constructor will be called. I'm going to create what's called a copy constructor. This is a copy constructor. It allows you to create a new copy of the of a book instance, possibly with different values, right? For example, I want a different value for rating, right? So for example, a different value for a rating, right? Public book, right? Now if I'm going to take another book to copy, book other, that, I'll call it that for now, and a new rating, double rating, right? Okay? Now I'm going to take a cue from this book over here, or this constructor over here. Now, instead of saying title, which I'm not given, right? This constructor takes the string, takes the author, the release date, rating, et cetera, et cetera. What I'm going to say is I'm going to say that dot title, because I want to copy that book's title into this book. I want to copy that book's author into this book's author. Right? Release date likewise, except for the rating. Right? The rating, I actually want to set it to this value, not that book's rating. I want that new rating over there, right? And so what I can do is I can say B is equal to new book of the old book and 4.73 or whatever. I'll just go ahead and do it like that. Right? Now the way that this is going to end up working is that all books will now have a rating of 4.37, right? 4.37, 4.37. This is just for demonstration purposes, right? This is a copy constructor because it takes a copy of another book, creates a copy, a deep copy of it, potentially, and you can change the settings on it if you really want to. There are a whole bunch of other patterns. We're only touching the tip of the iceberg here. They're called creational patterns. You can have, builder patterns and static factory patterns and stuff like that. We're not going to get into it that much, but there's more than one way to build a book, basically. Right? And I'm just showing you how you can do this through two different constructors, two different types of constructors. You can have as many constructors as you want. Over here in C, could I have multiple create book factory functions? I could, but then what would I have to do? I'd have to rename them. Because can I have two functions that are both named create book? Nope. I can have one that's create book with all data. Right? I could have create book via a copy or something like that. I would have to append a lot of information like that to the end of the function's name in order to get different function names. Right? So, constructors. Right? Constructors are special methods in a class that allow you to specify how an object gets built or constructed, right? Who would have imagined that we call them what they are, right? They're a constructor, right? You can define multiple constructors to allow a user to create an object in multiple different ways. You can make a constructor private or public. For example, that local date class, right? There is no public constructor there at all. If I tried to do something like this, local date foo is equal to new local date, right? 2022 1/1, right? There are no constructors. There are no public constructors. They made a design choice to make everything private, and follow a different pattern where you have, what was it over here? Where you have these, where is it? Release year. That's release year. Here, right here, release date, right? I've got static methods here that I invoke and give off the information. Then it takes care of all the data validation and then calls a constructor that's private and then gives it back to me. It gives that object back to me. It's just a different way of doing things, right? I imagine that they did that so that they could locate all of the validation data somewhere, within the class instead of in the constructor itself. So what they do is they validate the data, and then only if it's good data do they invoke the constructor. So let's go ahead and make this back into public and make this and get rid of this because we can't do it. Okay. Questions so far on Java classes? For those that have had Java before, have you been through all this? Yeah? Okay. All right. That's all. That's as far as we're going to go in object-oriented programmingness, as far as Java is concerned. Right? We've only looked at encapsulation. There are 4 pillars. There's abstraction, encapsulation, inheritance, and polymorphism. We definitely will not look at inheritance and polymorphism until next semester. We've looked at encapsulation, and abstraction is kind of implicit here. For example, remember when we were deciding how to define a date in C? We came up with a couple of different ways. A string, an ISO 8601 formatted string. Ultimately, we settled on, there was the Unix epoch, right? The number of seconds since we did this, right? Yes? No? All right. Unix time epoch. Right? So another way of representing time is through a single number. So currently, right now, it is right now the time is 1667835942334. It's counting up the number of seconds since January 1st, 1970. Right? That's one way of representing time. Another way of representing time would be an ISO 8601 formatted string, right? Where only computer scientists do it right because we've got a year, month, and date, all with leading zeros so that everything is perfectly lexicographically orderable, right? All you have to do is call strcmp and all the time will be from the past to the future, right? In order. The other way that ultimately the way that we did it though was what? 3 different numbers. So that begs the question of, well, how does local date do it? How did Java do it? Do we care? No, that's what abstraction is, right? There's just this local date. If you want to build it, you can go ahead and give it the month or the year, the month, and the day. And then it takes care of validation for you. It takes care of you can add a year to it or something, right? Release date dot add or dot at time or compare you can get have a bunch of getters here. You can compare it to another chrono date. You can ask what time it is, et cetera, et cetera. You've got a bunch of methods that you can invoke on this. How does it work? Again, who cares, right? That's what abstraction is. If we were actually really cared, we could jump into the class and find out, right? Let's see, where is the date? There we go. Guess what? 3 integers, a year, a month, and a day, right? By the way, that's actually 1 integer for the year, right? Why do we choose a short and a short? We haven't talked about shorts before, but those are 2-bit integers, or yeah, 2-byte integers, excuse me. And with 2 bytes, you can represent, it's 1 byte, right? Or Java short. It's 2 bytes, right? Yeah, 16-bit. So you can represent 2 to the 16 minus 1. That's the maximum value, 65,535. Why doesn't it use a full-on integer? Well, they're only 12 months. They're at most 31 days, right? You don't need the big, giant integer to represent that stuff. Right? But interestingly, they did exactly what we did over here in our book, in our C solution, right? Year, month, day. But they've got a hell of a lot more bells and whistles going on here. I mean, look at this class. over 2,000 lines of code, right? Just to get a local date implementation, right? And that's one class in one library. So to get it right, it's a lot. Right? We'll go ahead and remove that. Again, abstraction. Do we care that it's 2,000 lines of code? Do we care that how any of it works? No. Somebody wrote it, we simply just use it. That's the other pillar of object-oriented programming. Again, abstraction, encapsulation, and then inheritance and polymorphism next semester. Okay. All right. Let's see. Other conventions. Other observations, right? Class names should be upper camel cased. Right? Member variables should be lower camel cased. And this is why I adopted that same convention, that same styling for C, because it's such a good convention, right? In fact, I mean, Java is not too, it doesn't enforce these as rules, but all over the place it will say, do you really want to do that? Do you really want to do that? And even warn you about it. If you tried to create a class that did not follow that convention, it would probably say, that's highly discouraged, please don't do that, but go ahead if you want to, right? All right. One other thing. So, was I keeping track of all of the books? So I would create a book, and along the way, if it was the highest rated book, then I would go ahead and update the highest rated book. I would print out everything. Let's go ahead and get rid of that for now. And then at the end of this all, I would say that the highest rated book is blah. Right? Okay. I don't want to do that. What I want to do now is I want to keep track of all of the books. I want to have a collection of books, a library. Right? So let's go ahead and get rid of this stuff. Maybe move it down here, right, for the actual reports. And we'll go ahead and get rid of this as well. Right. So I've created a book, right, and I'm not doing anything with it now. Let's go ahead and put it into a collection. Right? Add the book to my library. Right? So what is my library going to be? A collection of books is a library, but how do I store them in Java? A what? An array. Okay, good. We immediately jump to an array list. Why didn't you say book library? There we go. What is that? That's just a regular old array. What would I need to know in order to create an array of 20 books? I would need to know that first line in the data file, 20, right? Because I want to create an array of them, right? Library is equal to new book of num records. Okay? Well, that's really limiting. What if I want to add a book later on? What if I want to remove a book later on? Et cetera, et cetera, et cetera. Right? So, what I want to do is I want to go with a full-on array list, or list, of books. This is my library. Is equal to new array list. Right? So for those of you that have had Java before, did you immediately jump to array lists and lists, or did you use old school arrays? Array, old school? At first, okay, good. And then they immediately said, okay, now we're going to stop using this crap. Oh, excellent. Things are changing finally, right? It used to be not that way, right? Even though this collections library is well over 20 years old. Right? In fact, that seems so useful. I'm going to go ahead and take that and put it into a function. Public list book. Load from file, right? And I'm going to put all that code into this load from file. Right? And in fact, I'll generalize it so that you give me the file name. Right? File name. There we go. And this library, once it's created and I've closed my scanner and everything, I will go ahead and return the library. Now I can put that into another class entirely if I want to, right? A library utils or book utils or something like that. Right? And my book, or my list of books, right? Library is equal to demo dot, what was it, load from, thought I made it public. static, there we go, sorry, dot load from file, the file that I was loading from before, right? That's so much cleaner now, right? All that, 4 dozen lines of code, 50 lines of code or whatever, right? Put that somewhere else so that it's not, gunking up the system, right? In fact, it's not relevant. I won't show that until later, maybe. But anyway, you want to, in general, a method or a function should do one thing, right? And you put it off over there, and you shouldn't have to do a bunch of things. For example, loading from a library, finding the highest rated book, finding the, what else did we want to do? Finding the worst book, the lowest rated book, finding all books written by Frank Herbert, et cetera, et cetera, et cetera, right? One function shouldn't do all three of these things. One function should do one thing and one thing only. So create a function to load it from the file, create a function to find the highest rated book, right? Book B highest rated is equal to demo.get highest rated book, right? Put that into a function that takes the library and then returns it for you, right? And print this out. The highest rated book was highest rated. Right, there we go. Now let's write this function really quick. Public static book get highest rated book from a list of books. Right? There we go. All right. So what are we going to do? We're going to keep track of a rating, right? Double rating. We'll go ahead and initialize it to -1 here. Right? There's a better way of doing this here. We'll look at it in a second. Right? In fact, there are two better ways of doing this. One of them we'll not see yet until we get into searching and sorting. Get highest rated book, and for each book, book B, in the library, right? A nice use of an enhanced for loop, right? So that I don't have to have for int I is equal to 0, I is less than n, I is plus plus, get the ith book, right? That's all in one line here. If b dot get rating, right? Nice use of a getter, right? I don't have to worry about this variable being off somewhere else entirely. If that's greater than the rating I've found so far, right, then I update bestest book to be B. And so I also need that. Book B best book. Right? I'll initialize that to null. Right? And then at the end, return best book. Now are we going to get the same result? Highest rated book was, oops, null. Oh no. There's my library. Oh, duh. What should I have done here? First of all, I should have put a to-do, right? To make sure that I didn't, that I came back and actually did it. But I never added the book to the library, did I? Library dot add the book. Now it should be Harry Potter. Yep. Oh, hey, it's not. Ooh. That's a good mystery. Why is it not Harry Potter? Greater than rating, best book is equal to B, return the best book. I'm not screwing anything up here, am I? Library.add. All right, this is nice. We have plenty of time here to figure this out. How should I start going about it? Immediately jump on Piazza and say, nothing's working? What should I first do? Yeah, set a breakpoint and invoke a debugger here. Right? So we're in the get highest rated book right now. Let's go ahead and open the library. Well, there's the library. There's Harry Potter and the Deathly Hallows, 4.62, right? Right? You can go ahead and scroll through these and read them all, or you can actually just, highlight that library variable and then it'll print them all. But of course, that's not very useful. Right? All right, so let's go ahead and start running through this. Best book. All right, so if the rating is greater than the rating I found so far, then the best book should get updated. Let's go ahead and highlight that and see if it gets updated to the next book, which should be whatever the first book was. Right? There we go. So the best book is Harry Potter and the Deathly Hallows with a rating of 6.2. Okay. All right, the next book here, whatever the current book is, B is now The Name of the Wind by Patrick Rothfuss, 4.55. If I get next, then the best book should not be updated. Oh, but it is. Ooh. Oh, because it is better. What? Ah, there we go. So let's come back over here to my Java perspective. Right? I updated the best book, right? But I never updated the rating to be the book's rating. It was always ever going to be -1, which gives me the last value, the last book that you found here, 4.45, Game of Thrones. Right? There we go. That's one way. Another way would be to call a built-in function somewhere, but that's going to require us to get into searching and sorting, right? There is a collections dot get or not, is it max, right? Get the maximum thing, right? Well, what does the maximum thing look like? To understand that, that's going to be not the next module, but the module after that, after your exam. But just as a preview here, if I cut and pasted this code and got the lowest rated book, what would it look like instead? Well, should it be -1 now initialized? All books are going to be higher than that. So let's go ahead and initialize it to 10, something like that. And it won't be the best book anymore. It'll be what? Let's go ahead and refactor, rename that. It'll be the worst book. There we go. And I'm not checking to see if the rating is greater. I am checking to see if the rating is less. So other than the variable names, which really doesn't matter, and other than the initialization of this, right, what is the only difference? It's whether or not you have a greater than or a less than sign here. Seems like to me like there's a lot of repeated code here. Can we generalize this thing so that I only have one function? Right? One function to get the extremal element. If that extremal element is minimum, if that extremal element is maximum. Right? And that's what we're going to look at with respect to searching and sorting. That thing is called, you've already seen it before, that thing is called a comparator. Right? Something that returns something negative, 0, or something positive, depending on the relative ordering of two things. Right? This is just a preview. Right? I want to do the last thing over here, though, as the last item of the day. I want all books written by Frank Herbert. Okay? Public, static, get Frank's books. Right? Now over here in Java, that's going to be super easy. Right? What do? I need a new list of books. Right? Frank's books equals new array list. There we go. And then I'll return Frank's books. Before we do that, we should, list book. We should make sure that the other two work, right, that we fixed our bug. So here's the highest rated, here's the lowest rated, right? Lowest rated. And get the lowest rated book. Lowest. So what's the lowest rated book? Dianetics. 2.33. This is real data, by the way. Right? It's not just my personal opinion. Okay? I've never actually even read it. All right. So those two things work. Okay? Let's go ahead and get Frank's books. What do I need to do? I need to iterate through all the books. Right? And if the book was written by Frank Herbert, right? For each book, if B was written by Frank, right, then I will go ahead and add it to Frank's books. dot add B. How do I know if it was written by Frank? What's one way that I could tell? B dot get author dot get their last name. Oops. What have I not done? I don't have any getters or setters here. That's all right. We can check, clean that up in 2 seconds. Right. Select all the getters, and I'm done. Get first name, get last name, and get the date of birth, etc., etc. Right? Get author dot get last name. Right? And if that's a string, if that equals Herbert, then Frank must have written it, right? Has anybody read the Dune series? No? Okay. Well, he wrote 5 main books before he died, and after he died, his son took over. His son was named Brian Herbert. So is it enough to just get Frank's books by looking at the last name? No, we'd get, we'd get Brian's books as well, which I've never actually read, and I don't intend to. Right? All right, so B dot get author dot get first name dot equals Frank. Right? So if it was written by Frank Herbert, a man named Frank Herbert, right? Then we'll go ahead and add it to Frank's books here. Now, is that really enough? What if there happen to be 2 Frank Herberts out there, right? Now, I'm not sure about like guilds and stuff like that, like screen actor guilds, for example. As long as there are 2 actors that are actively working or recently worked, you cannot use the same stage name as somebody else, right? As if you're part of the guild or if you're part of the union. And so for that reason, a lot of actors have had to change their name, right? Like Nicolas Cage, that's not his real name. I forget what his real name is. But people adopt a stage name so that they don't get confused with somebody else, right? Or so that they can avoid the appearance of nepotism. Like, for example, Emilio Estevez. His father is Martin Sheen, right? So Charlie Sheen chose to keep his last name when he became an actor, but Emilio Estevez thought, no, I want to go out on my own, right? And not have to live with the Sheen name, right? So people change their names all the time, right? I don't even know, but Frank Herbert is probably his real name. But there might be another author out there named Frank Herbert, right? With the data that we have, there's really no way to disambiguate that. Right? You would have to come up with some sort of a unique identifier. This is what we do with people all the time. If there are 2 Frank Herberts in the United States, born in the United States, how do we distinguish them? How do we identify people in the United States? Uniquely. No, everybody has it. Social security number, right? Etc. Right? All right, so we don't have that data here, but it is a concern with our data. Right? So let's go ahead and get this list of books. Frank's books. Frank's books is equal to get Frank's books from my library. And let's print that out. Or let's go into a loop here. For book B in Frank's books system.out.println B. There we go. Why am I not using printf and formatting it as a string now? Because I've defined a toString method. Right? So let's jump into the class over here. Right? The toString method will take care of all that formatting for me because I've encapsulated the functionality into the class itself. Right? There's number 3. Grouping functionality that acts on that data with the data. I didn't have that over here in C. Right? If you wanted to convert it to a string, that is a function that is completely separate from the structures itself. Right? So you can see that the other 2 things are really nice things to have. Right? But that means that you've got a modern object-oriented programming language. Right? Okay? Not an old school language like C. Let's see. Let's run this really quick and make sure that it works. There. Dune by Frank Herbert. Dune Messiah. Children of Dune. God, Emperor of Dune. Heretics and Chapter... Oh, I've got all 5 of them. Excellent. Right. I guess... I'm looking at the ratings. I'm kind of, they kind of go down over the years, but that, like this is definitely, the Children of Dune is the second one. It goes down a little bit, and then the rest of them go down even further. Like, no, they're all perfect 5s. Go out and read them. Right? All right, any questions? Because what we're going to do probably starting next time here is I want to do the same thing. Over here in the book demo, I don't want to have to keep track of the book and print it out every single time. I want an array of books. Right? So what would that look like? Well, we don't have an array list, do we? Nope. So what we're going to have to do is create an array. An array of books. Book library. Right? How do you create an array of anything? With a call to malloc. Right? How many books do you want? Well, fortunately, we're cheating, right? And the num records is in the first line. Right? Without that cheating, what would we have to do? We'd have to, just like you've done now with your file IO stuff. How many lines are in the file? You have to go through and count them up. Then you can go back and reload them so that you know exactly how many lines there are. Right? Num records, we're cheating here by reading that first line, and it says that there are 20 records, times size of book. There we go. Once I've set up my memory, now I can go through and assign those values. How would we end up doing those two reports differently? A function, right, that returned a book. A function that returned a book, maybe. A function that returned an array of books. Right? So we'll look at that next time. Okay? A little bit harder in C, but it's the same exact concepts. Right? All right, any questions? No?